Alright, we want the final value of a $6,000 investment for 9 years with interest earned at a flat rate of 5% per annum. Flat rate means it's simple interest. So it's 5% per annum simple interest for 9 years. How simple interest works is we can just take this 5%, say it's happening for 9 years, so we can multiply that by 9. Which means that we are earning 45% interest total. Okay. Which means if you want the final value of this investment, we just need to increase our initial $6,000 by 45%. Okay, it only works like this for simple interest. For compound interest, we have to update the values every single year or every month. But because it's simple interest, we just go 5% times 9 is 45% total. We don't care about updating values. So how do we increase $6,000 by 45%? Well, we have our initial 6,000, so it's going to be like a block like that. That's 100%. That's what you start with. And then we tack on an extra 45%. Okay, which means that in total we have here 145%, which as a decimal is 1.45, and we have this much of the initial $6,000. Okay, and so this gives us D as our answer. Okay. What's wrong with A? Well, A is nonsense. You're adding the percentage. That's not how percentages work. You have to take percentages of the initial value. B would be correct if it were compound interest, but it is simple interest, so that's a no-go. C only calculates interest, but doesn't calculate the final value. So that's what's wrong with those three. Okay, price of an item costing X dollars increased by 9% due to inflation. What's the new price? So same thing as one before. We have a 100% starting value. That's whatever the X was. Then we need to add on to this an extra 9%. Okay, so that's an extra 9% there, which means that again, in total, what we're going to have is 109%. Okay, and that leads to 1.09 as a decimal of the initial price, so whatever X was. Okay, so that gives you C as your answer. B and D are adding, it's nonsense. A is the inflation amount, but not the final price. Okay, which of these is correct? Well, this is just, hopefully you studied the different types of insurance. Compulsory third-party insurance is not optional, it's compulsory, so that's kind of dumb. No go. Comprehensive motor vehicle insurance covers damage to my own car. That is true, that's what it's good for. So third-party insurance, if it's compulsory, it doesn't cover damage to vehicles or property. Okay, compulsory only covers damage to people. And D is stupid. It's illegal, don't do it. So I guess one takeaway from C though is that compulsory third-party insurance, if it's the compulsory type, let me square that one or rectangle that one. Okay, compulsory only covers damage to people. That's one big difference between compulsory and comprehensive or third party. Okay, so that's that one. A coat was sold with a 35% discount at a clearance sale. If you paid $234 for it, what was original price? Alright, we're going to do that rectangle thing again. Always do that. So some original price, which we might call this 100% original price. We'll call it P. Okay, so that's the original price. We then had a 35% discount, so that means that 35%, let me draw that here, got taken off. So then you got to think, well, what percent's left over? Well, that means that only 65% is left over. Okay, so 65% is left over, and that's how much we must have paid for it. Okay, so what we paid was only 65%, so 0.65 of the original price. That's how much we paid, because we had the 35 discount. But that is $234. And we want to know what's P now. Well, it's easy. How do you undo multiplication by something? You divide. So it must be 234 divided by 0.65. So we quickly do that, and we get $360. Okay, what was the amount of discount given on this purchase? Well, we're just going to see what's the difference between what I paid and what the price was. So it used to be $360. I only paid $234. So what's the difference? What discount did I get? So I subtract that, and I get $126 discount. You can also check that this should be the same as doing 35% of 360. Okay, so take and check your answers correct, because it's a 35% discount on that 360 price. So I can check that real quick, and yeah, that's the same thing. Alright, George has paid an annual salary of $142,000. During some 3 weeks, he was given a 14% bonus on top of his usual pay. How much did he earn in those 3 weeks? So first step is to work out how much does he normally earn in 3 weeks. So we think, what's the normal 3-week pay? Well, it's $142,000 for a whole year. Okay, so to get the weekly pay, we divide that by 52. That's how many weeks there are in a year. Okay, about 52. Then to make it 3 weeks, we better multiply that by 3. So 142,000 divided by 52 times by 3, I'm getting 8192.31ish. Now I'm going to get that number and keep it in my calculator. So now we have a bonus of 14%, which means we need to increase by 14%. Okay, so once again we can think of 100% increase by 14%. I might do this a bit quicker now because we've done this quite a few times. So we're going to increase by 14%, and so that means that in total it's 114%, or 1.14. Okay, so that's the multiplier, 1.14 multiplier on this 3 weekly pay. So I kept that number in my calculator. I now increase by 14% by multiplying 1.14, and I get 9339.23. Okay. Calculator purchased with an included 10% GST of 2.54. Calculate the before GST price of the calculator and then the total price. So again, how GST works, if you watch my previous video about that, there again is an initial price. You see how this features a lot in this topic. Okay, that's some sort of before GST price. We'll call this P again. Okay, so that's a before GST price. Then there was some GST added to it. And we are told a couple of things about this. One is that it is 10% of this original price P. But the other thing we're told about it is that this block has $2.54. Okay. So that means 10% of the initial price was $2.54. Okay, so we can write this like 0.1, so 10% of P is 2.54. Okay, now at this point you can of course divide by 0.1, get your answer, but you can also see if I know that 10% is 2.54, to get 100% I can just times by 10. Okay, that does the same thing, it's the same calculation really, but I can just make it a bit easier. So I times by 10 and I get P is equal to $25.40. Okay, so 10% included is $2.54, so that 100% original price is that multiplied by 10, so 25.4. And we want the total price now. Well, total price is equal to the original price, which is 25.4 plus the GST, so 2.54. Okay, and so we get 0.4 plus 2.54, and I get 27.94. $27.94. Okay, well, there's a couple of ways we could have done that. We could have multiplied that by 11, we could have multiplied that by 1.1, could have been, could have been any of those things. Okay, graph here, want the equation of the line. Equation always has two things. It's going to be y equals, and I'm going to use a different color here because we need to have the m, that's important, and the x plus a b. Whoa, that was weird, the color full changed on me. X plus, let's try that again, b. Okay. Alright, so these are the two ingredients we need for any lines equation. Okay, we need m, which is the gradient, and we need the b, which is the y-intercept. Okay, so gradient was the slope, or this was the rise or run. The y-intercept is where the line touches the y-axis. So let me do this one first. Let's do this thing here first. Where does the line touch the y-axis? So it comes down, comes down, comes down, touches the y-axis right there, so that's going to be 400. Okay. Gradient, a little bit more complicated. Okay, so it's a rise divided by run. So you pick 2 points. We only really have 2 points. Okay, it's easiest if we draw a triangle connecting these 2 points. So let me try that. Okay, so I come down here and I draw a line right about there. I draw a line right about there. Oh, first one's too short. That's alright. Okay, patch it in like this. Okay, so I've got a triangle here between 2 points that I found, or 2 points that are given to us, and you have to think how far up, how far across. So from here to here, how far up are we going? We're going up by 600. How far across are we going? We're going across by 12. Okay, and so from this we have that the gradient is how far up divided by how far across, which in this case will be 50. Okay, so once you have those two ingredients, 50 is your gradient, 400 is your y-intercept, your equation's kind of easy now. Y equals gradient, so 50, x plus 400. Okay, so y and x are left variable because you can move along the line, but the gradient won't change, so the steepness won't change, and the 400 of course won't change because that's where the line cuts the vertical axis. Calculate the value of y when x equals 30. Well, that's easy now. You sub in x is 30 and see what happens. So y will be 50 multiplied by x, which is now 30, then you plus 400. Okay, so 50 times 30 is 1500 plus 400 is 1900. Alright, two graphs show future value of $100 when you're investing it at the same interest rate, but one is simple interest, one's compound interest. So which one's simple interest? Is it the blue or the red one? Well, it's the blue one. How do we know? because simple interest increases in a straight line. Compound interest is the one that gets faster and faster and faster as it goes. It's the exponential kind of curve. It's going faster as it goes. Okay, so that's why we know it's simple interest. Alright, the difference in interest earned at the 30-year mark. Well, at 30 years, the compound interest has earned 1,006.27, and the simple interest has only earned 340. So I take away 340. Strictly speaking, these numbers are not how much it's earned, it's the final value, but if I look at the difference in final values, that's also going to tell me the difference in interest. Okay, so it's a little subtlety there. I might have misspoken just then. These are really final values. They're not the interest, but the difference will still give me the difference in interest because I started with the same amount in both of them. So 1006.27 take away 340, I get 666.27. Alright, that's my difference in interest. Now I use a simple interest graph to calculate the interest rate. So the interest rate has to do with gradient. That's the first thing. Okay, this is related to that idea of gradient. Okay, so what is the gradient of this line? Well, in 30 years, okay, so in 30 years, I might not draw the line, it's a bit too shallow. So in 30 years, it's gone from $100, which is that initial investment, so maybe I'll label that there at least. This thing here must be $100. So we can say in 30 years, it has earned from 100 to 340, so it's earned 240 in interest. Okay, and so that's like the rise, that's like the run. Okay, so it's risen by 240 over a run of 30 years, which means the gradient is 240 divided by 30, which is 8. Okay, now 8 wouldn't automatically be the interest rate. I said it's related to the interest rate because 8 is actually not a percentage. 8 is a flat amount of money that is being that's being earned in interest every single year. So the last step really should be to look at this flat amount of interest earned, 8, as a fraction of the initial amount, okay, of this initial $100. Okay, so that is 8 divided by this initial $100, and so that gives me 8%. So in this case, just because it was $100, okay, the 8 is the same as the percentage, but generally it's not going to happen. Okay, your gradient will tell you the flat amount. Then you have to place this flat amount as a fraction of the initial investment, and that's going to give you your interest rate. Okay, so I might just write that here so it's clear for those just looking at the solution. So gradient told us that we are earning $8 per year. Then there was a next step in taking this $8 as a fraction of 100, where the 100 is the initial investment. Okay, and so that gives me 8% interest rate. Okay, so don't skip that step of looking at the interest as or annual interest as a fraction of that initial investment. Alright, write down the equation of the simple interest graph using f for future value. So f must be the y value, the future value is f, so I can call that the f-axis. And what do we want to use? T for years, so that's our t-axis. So f is equal to, like y equals mx plus b, I calculated the gradient's 8, so it must be 8. Instead of x, I'll use t, because that's the new letter. So y equals mx, just with different labelings, plus b was where does the graph touch the y-axis? Well, that's 100. Okay, so last one on this, what would be the final value of the simple interest investment after 60 years? Well, if I put t as 60, the f would be 8 times 60 plus 100, that's 480 plus 100, so 580. Okay, taxable income of 92,800, calculate the tax payable on this income. So first thing is that we are sitting inside this bracket here, which means my tax will be this one. So it'll be 17,542 plus 37 cents, so 0.37 for each dollar over 80,000. So how much over 80,000 are we? We are 92,800 minus 80,000. This gives you the difference, which will tell you how much over 80,000 you are. Okay, so we type that all in, 17,542 plus 0.37 times 92,800 minus 80,000. I am getting $22,278. Alright, Medicare levy, 1.5% of taxable income. So, what's that going to be? 1.5% of her income, 92,800. So 1.5% of 92,800. I'm getting 1392. Okay, so her total tax then that she's got to pay will be this Medicare stuff plus the taxable, or tax payable on the income. So I'm going to add the 1392 to the previous answer, which is 22,278. Okay, so real quick. So plus 1392, so 23670. Okay, that was just adding up these two. So she paid 25,400 in tax as she went this year. So the refund must be the difference. Okay, so she only needed to pay that much, but she ended up paying that much. So the refund would be the difference. 25,400 minus 23,670. 1,730. Okay, I think this is probably the trickiest type of question. X dollars was invested into an account paying simple interest at some fixed rate. In 5 years' time, you'll have a total of that. I want the interest rate. A similar sort of things could appear, maybe not in the context of simple interest, but just this ability to work with fractions and these unknown numbers is important. Okay, so it's invested into some account paying simple interest at a fixed rate which we don't know, so we'll call this fixed rate R. Okay. What I do know is that the interest earned is always equal to the, or simple interest is always equal to the initial amount multiplied by the rate multiplied by the time, so 5 years time. Okay, so we'll just call that 5rx for now. Okay, alright, but in 5 years time the account will have a total of this, so how much will there be in total? Well, it must be how much I started with plus the amount of interest I earned. Okay, and so that will give me a total of 31x over 21. Okay, so how many x's do I have on the left? I've got 1x there, I've got 5rx there. Okay, I could add them together if I wanted to, but I think we're not used to doing that sort of thing. So what I might do instead is I might leave this 5rx here alone, okay, because I'm interested in working out this r anyway. So I might leave that one where it is, and I'll get rid of this x by moving it and subtracting it to the other side. Okay, I'll put that over here. So that means that I have 31x over 21 take away 1x. Okay, and that's where I might need to know a bit of fraction addition stuff. So we need to have a common denominator of 21. So I go 31x over 21 minus, if I wanted 21 on the bottom, I need to have it on top as well. So 21x over 21. That's just x. Okay, so that just became that. Make it a little bit nicer. Okay, so now I have 31x over 21 minus 21x over 21. So how many x's do I have over 21? 31 minus 21 is 10. And that's equal to 5rx. And maybe now we can see a bit clearer that actually the x's can just cancel each other out. So I can just divide both sides by x, and that will just wipe it out from both sides. So I don't really need that anymore. Okay. Oh, I should just do one line so people can see. Okay. So now we have 5r equals 10 over 21, and now that's much more doable. I just go divide off the 5. So divide by 5 there. I divide that by 5. I could either calculate this or see that 10 pieces divided by 5 is just 2 pieces, and so that means that r equals 2 over 21. And if I type in 2 divided by 21, it gives me 0.09523 blah blah. 95238 something something something. I don't care about that because the question says that I just need 3 significant figures. So again, for significant figures, I don't worry about these leading zeros. I dump those ones. And I just take the 9.52 as a percentage. Okay? So that's significant, significant, significant. Don't need to round the 2 because it's a 3. So I take this as a percentage and say r equals 9.52%. This is a hard one. Okay, so don't worry if this is the only thing you don't get, you'll be fine. Alright, see you in the next one.